In this case, dealing with the counting, we require much greater use of formulas, as we consider 5 different methods for counting the number of possible outcomes in a variety of situations. And not all counting problems can be solved with these 5 methods, but they do provide a strong foundation for the most common real applications, and that's what we are going to look at.
For a sequence of events in which the first event can occur n1 ways, the second event can occur n2 ways, the third event can occur n3 ways, and so on. The total number of outcomes is n1 times n2, etc. For a sequence of 2 events in which the first event can occur m ways and the second event can occur n ways, the events together can occur a total of m times n ways.
So that is known as the fundamental counting rule, or multiplication counting.
Factorial rule. The number of different arrangement order matters of n different items when all n of them are selected is n factorial. The factorial symbol denotes the product of decreasing positive whole numbers. By special definition, 0 factorial is equal to 1. The factorial rule is based on the principle that the first item may be selected n different ways, the second item may be selected n minus 1 ways, and so on. This rule is really the multiplication counting rule modified for the elimination of one item of each selection, on each selection.
So that's the synopsis of what's coming up. Let's start with a simple example.
A paint manufacturer is making different paint categories as follows: color, red, blue, white, black, green, brown, yellow; type, latex or oil; texture, flat, semi-gloss, high gloss; use, outdoor or indoor. How many different kinds of paint can we make if we can select one color, one type, one texture, and one use?
Okay, so this is the basic multiplication rule, or the fundamental counting rule. So simply put, we just see the product. The product of what? How many colors do we have? How many types do we have? How many textures do we have? How many uses do we get out of it? And we replace the numbers that are given. And so we see that we have 7 different colors. Then the type, we have 2 different types. Textures, 3 different types. Use, 2 different types. And plug in. So this is a simple case dealing with the fundamental counting rule.
When making random guesses for an unknown 4-digit passcode, each digit can be 0, 1, ... 9. What is the total number of different possible passcodes? And given that all of the guesses have the same chance of being correct, what is the probability of guessing the correct passcode on the first attempt?
First, it is important to know that when we go from 0 to 9, that means we have 10 digits. We want a 4-digit passcode. So basically we have 4 spots. In each case, since there is no restriction, we can use 10 digits in each case. There are 4 of them, 10 to the power of 4. If there are 5 of them, 10 to the power of 5, and so on. So 1, 2, 3, 4 different spots. So it's the simple case of multiplication rule, or the fundamental counting rule. 10 to the power of 4. Everybody has the same chance of being correct, so it's just simply 1 out of 10,000. N of C standing for being correct. N of S standing for the sample space or sample size. 1 over 10,000. All right, counting.
Multiplication counting rule, the fundamental counting rule. For a sequence of events in which the first event can occur n1 ways, the second event can occur n2 ways, the third event can occur n3 ways, and so on. The total number of outcomes is n1 times n2 times n3, etc. For a sequence of 2 events in which the first event can occur m ways and the second event can occur n ways, the events together can occur a total of m times n ways. And 2 factorial is the product of all positive numbers from 1 to a number.
We already discussed the multiplication, or the fundamental counting rule. N factorial, it simply starts with n and it goes down all the way to number 1. We multiply those numbers. So if we said 10 factorial, that means 10 times 9 times 8 all the way to 1. 1 factorial and 0 factorial are 1. Actually, 0 factorial becomes 1 because of the definition of a combination.
Permutation is an arrangement of objects in a specific order. Order matters. The letter arrangements of ABC, ACB, BAC, BCA, CAB, and CBA are all counted separately as 6 different permutations. When n different items are available and r of them are selected without replacement, the number of different permutations when order counts is given by
NPR is n factorial over n minus r factorial. N factorial, you can go all the way down to r items and then times r items and get rid of it. But what I want to mention is different notations. By the way, NPR, this is the way you write it if you want to use a TI. And what it means is you put the number first, then you look for NPR, and then you put the R first. I will show you in a moment as far as how you use a calculator if need be, but conceptually is really not difficult. Now, NPR, we can write it as P and then NR. In case you see that, that has the same meaning. That means permutation of N objects when we choose R of M only. And R is always less than or equal to n. Can it be equal to n? Yes. Can it be larger than n? Absolutely not. And basically, you're dealing with different objects, and order is important. And a simple example that ABC, for example, is not the same as ACB. It's very simple. Think about a code, a password that you want to use. Even if we want to go with something as simple, then all we have to do, change the order, and it's a new password. Order is important.
When some items are identical to others, the number of different permutations, order counts, when n items are available and all n of them are selected without replacement, but some of the items are identical to others, is found as follows. N1 are alike, N2 are alike, and Nk are alike.
In the third case, we are dealing with different items. But what happens when some of them repeat? Now the formula changes. The permutation rule changes to n factorial over n1 factorial times n2 factorial all the way to n sub k. And finally, combination.
Combination is a grouping objects. Order does not matter. When n different items are available, but only r of them are selected without replacement, the number of different combinations, order does not matter, is found as follows.
Pay attention to the difference between 3 and 5. In the case of a 3, A, B, C, and ACB, and so on and so forth are different. But number 5 says it doesn't matter. ABC is the same as ACB. So when would that be? There are cases that you may want to choose, let's say, a committee of 3 students, let's say, from the class. Then order is not important. You want 3 students. So that becomes a combination, and it is up to you to recognize that. However, if you said instead of just committee of 3 students, we said we want a committee of 3 students such that the first one is the president of that committee, and the second one is vice president, and the third one is the treasurer, and so forth. Now, order makes a difference. So you have to pay attention to the question and see what happens to the order. Now, in this case, basically, the answer is n factorial over n minus r factorial times r factorial. What I want you to pay attention to is the notations. We have 3 different ways. If you put it as a parentheses, in essence like a pair, that means a combination. Or CNR or NCR, that works the same way.
We ought to travel to visit the presidents, all from different age groups of 5 different companies. How many different travel itineraries are possible? If the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest?
All from different age group. How many different travel itineraries are possible? There are a couple of different ways to approach this. So let's look at various approaches. One is simply n factorial. The other one is that may make it a little bit easier to understand. We have 5 spots to fill. So we put the numbers that we have. First and foremost, we have 5. So we are multiplying those. Now the next one, we no longer have 5. One of them is gone, 4. And then we go down in the same manner. And so you can go with the simple multiplication rule. So we can use n factorial, or we can use the multiplication rule, or we can see that it's a permutation. If you look at the top, I'm showing you here how to use a calculator to get to a factorial. In order for you to come up with the answer for a factorial, you have a choice. Calculate it by hand. Well, 5 times, so you use a calculator. But if it's a larger number, it's easier just to use a calculator. So what do? First, you put the number n, then you press math, then select probability, then select factorial, and enter. If you want to use permutation or combination, you start the same way. You start with entering n, you press math, you select PRB or probability, and then you select NPR or NCR, depending upon what you need, and then you enter the value of R. Finally, for this question, if the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? There's only one way to have the proper order, and it's only 1 over the total size N of S, which is 1 out of 120. I want to quickly show you how to use a calculator. If we want to use a factorial, in this case 5 factorial, then we press math, we go to the right, and then we bring it down to the factorial. We press enter, it shows 5 factorial, and it is 120. Using permutation, the same thing again, 5, and then math, going back to PRB, going down to NPR, and we're going to choose 5, and it gives us 120 again. So this is how you would use the calculator to speed up the process. Here's the next example.
Business owner has a choice of 5 locations in which to establish the business. She decides to rank each location according to certain criteria, such as price of the store and parking facilities. A, how many different ways can she rank the 5 locations? B, if she wishes to rank only the top 3 of the 5 locations, how many different ways can she rank them?
This is practically the same as the previous example. And so, again, you can use the fundamental multiplication principle. We have 5 locations. Those are the choices. So you establish just 5 spots and you multiply, which means the first, the second, and so forth. So we have those, and that gives us 120, or you can use a factorial. Either way is fine. You can use a factorial in the same manner, or the permutation, and no matter what, all of them will result in the same thing. So multiplication principle, using a factorial, or permutation, it's the same thing. The second one, we only want 3 of it. So again, we have a choice. We can say, okay, we want 3 of it. And so we go 5, 4, 3, and that's it. Or you can use permutation, 5, choose 3. Sometimes this notation is used. Both of them mean the same thing. End up giving us number 60 as the answer. So we want to choose 3 out of 5.
TV shows 7 ads to use on a program. If we select 1 for the opening, 1 for the middle, and 1 for the ending of the show, how many different ways are possible?
The very first thing is to answer this question. Does order matter? You have to realize order is important simply because of the way they have told us. 1 for the opening, 1 for the middle, and 1 for the ending. So where do we use that makes a difference? Do we use a specific ad for the opening or for the ending or for somewhere in the middle? Okay, so where do we use that? So that's why order is important. So you've got to ask yourself, order is important or not? And you have 7, you want to choose 3 from. So your N is 7, your R is 3, but is it permutation or combination? That's what you want to answer. So it's simply a permutation. 7 factorial over 4 factorial, 7 minus 3, or 4 factorial. What I want to show you is this. Obviously, you can use a calculator, it's fine and then. But if you were to simplify it by hand, how would you do that? A fast and easy way is very simple, is as follows. You look at the smaller of the 2. The smaller of the 2 is the 4 factorial, so you keep it intact. Number 7 means multiply 7 all the way to 1. Number 4 means multiply 4 all the way to 1. So wherever you stop, you can change it to a factorial. For example, you can say 7 times 6 factorial. But it doesn't help us. Instead, we got to go 7, 6, 5 times 4 factorial. Why do we do that? Because we have the same thing down here. They can cancel each other. It's a simple way of approaching that. 7 times 6 times 5 is the answer. Or you can go with the simple multiplication principle. The first one, okay, we have 7 choices. So for opening, for example, I'm going to put O. For opening, we have 7 choices. Then for M, for the middle, since 7 is gone, one of them is already gone, we have only 7 minus 1 or 6 choices. And for the ending, then we have only 5 more left. So their product is the answer. So either way, it will do the job.
A department musical director will select 2 musical plays to present in a year, one in the fall and one in the spring. There are 9 to pick from. How many different possibilities are there?
We are using 2 musical plays, one in fall and one in spring. That means order matters. So you go with the permutation, and P9, 2 means 9 factorial divided by 9 minus 2 factorial. That's how we get 9 factorial over 7 factorial. So the top can be simply 9 times 8 times 7 factorial. They cancel each other, and the answer is 9 times 8. Or you can say there are 2 spots. For the first spot in fall, we have 9 to choose from. The second one for spring, we have 8 left, and we use the fundamental principle of multiplication. And we end up with the same answer. 9 times 8 equals 72.
An editor has 8 books to review, and he can only use 3 reviews in his paper. How many different ways can the 3 reviews be selected?
The question we should ask is very simple. What about the order? Does order matter here?
No.
No, and that's it. Extremely important that you read the question and decide whether order is important or not, and why. We are looking at 8 books, and we're just going to choose 3 of them, and that's all that matters. Order is not important. Therefore, you use a combination. And so this is another way of writing combination, format, any of them is fine. And so combination of 8, choose 3, that's the most important. This is n factorial, which is 8 factorial, over r factorial, which is 3 factorial, times n minus r factorial. By the way, whether you put the r factorial first or n minus r factorial first, it makes no difference. Now, again, I want to show you how you can simplify it by hand if need be. The largest number is 8, and the next largest number is 5. So in the denominator, you keep the 5 factorial. In the numerator, you can write 8 factorial as 8 times 7 times 6 times 5 factorial. And the 3 factorial in the denominator must be written as 3 times 2 times 1. And so we can get rid of the largest factor between the top and the bottom, which is 5 factorial. Number 6 and 3 times 2 are identical. So you're left with 8 times 7 over 1. And that's your answer. Just in case, you can write the permutation divided by r factorial. It's the same calculation. You don't have to worry about that at all. I'm mentioning it just because of the relationship between the combination and permutation. You don't have to worry about that at all. When you compare the formula for permutation versus combination, you see that if you divide the permutation by r factorial, it gives you the combination formula. Okay, I just wanted you to notice that, that's all. We're going to look at the next example.
In a club, there are 7 women and 5 men. How many different possibilities are there? A committee of 5 persons is to be chosen as follows. A, 3 women and 2 men. B, 2 women and 3 men. And then C, 5 persons.
So let's see how this thing works. The way this is telling us is that we are interested in a committee, and the restriction, for example, for part is that we want 3 women and 2 men, and order is not important. Because that's the first thing you should ask yourself. Is order important? No. Okay, we just want 3 women in any order, we want 2 men in any order. So it is really a combination of 2 rules, a combination and fundamental multiplication principle. Women and men. How many women? How many men? The way we come up with the women is a combination of 7 choose 3. Same thing for men. Combination. Combination of what? 5 choose 2. So now the fundamental principle of counting says multiply these 2 numbers. So all we have to do, find each case, multiply by each other. And that's what we are going to do. So we are going to find those and calculate them and multiply. So with that being the case, the first one is 7 factorial over 3 factorial r factorial, okay, times 4 factorial. The next one is 5 factorial over 2 factorial times 3 factorial. And so 35 possibilities for women and 10 for men. And we end up with the product of 350 as the answer. Now we are looking at a slightly different type. In this case, we want the other way around. We want 2 women. So we have to choose combination for women would be C7, 2, and we want 3 men, C5, 3. And we do exactly the same thing. We calculate each piece using the combination formula. The first one is 7 factorial over 2 factorial times 5 factorial. And for men would be 5 factorial over 3 factorial times 2 factorial. And we simplify. We multiply them, and we end up with 210. By the way, one way to do that, you can say for this one, 7 factorial, 2 factorial, 5 factorial. Then this is 5 factorial, 3 factorial, 2 factorial. So if you write it in this manner, you can drop the 5 factorial. Now, by the way, 2 factorial is 2 class, and 3 factorial by now you know is 6, or you just write down 3 times 2 times 1 and then do the math. This is another way of doing it. Again, simply dealing with fractions. Finally, it is asking for 5 people, which means there is no restriction. So in that case, again, it's a combination, but it's a combination of total. Total is adding these 2 numbers. We have total of 12 people, and we want to choose 5 of them. And order is not important, and it simply becomes combination of 12 choose 5, which is 12 factorial, over 5 factorial times 7 factorial. When you go through the process and simplify, you get 792. The denominator is 5, 4, 3, 2, 1, and I keep the 7 factorial. And so the top is 12 times 11, 10, 9, 8, 7 factorial, and they cancel each other. And then you can simplify things. For example, you can drop the 12 and 4 times 3 and take it from there. Maybe, for example, 2 and 5 can be dropped. 2 and 5 with 10 and take it from there. That would be the fastest way to do the simplification of the fraction and putting it in lowest. So here's the next one.
A store has 6 TV graphic magazines and 8 news time magazines on the counter. If 2 customers purchased a magazine, find the probability that one of each magazine was purchased.
Let's see how we do that. First, let's write it in a manner that it's easy to follow. TV graphic, we want to choose 1 of the 6 magazines. News time, we want to choose 1 of the 8 magazines. And therefore, we have a total of 2 to choose from, a total of 14 magazines. And so what we want is to find the probability that 1 of each magazine was purchased, and it's a combination in the following manner. The probability is defined as the number of outcomes for the event of interest over the sample size. First, I want to discuss the sample size, the total possible outcome. I want to discuss the sample size. Is combination of 14 choose 2. That would be your sample space as far as the size is concerned. The first one, really, you have 6 outcomes. The second one, you have 8 outcomes, meaning to get the first one is C combination of 6, choose 1. And by the way, it becomes 6. And the other one is the combination of 8, choose 1, and it becomes 8. And while we are at it, let me just give you this C and 1 is N when you calculate it. So whatever, when you're choosing 1 out of it, okay? Whatever the number N is, that would be the answer. And you can actually go through the, I highly recommend you look at the proof of that, which means you just try to evaluate. So it's very simple. Now that we know that, so that's the sample space, one of which would be the product of the 2 simple multiplication principle. And so probability of one of each is N of one of each over N of S. That's why I think, to me at least, when I'm doing probability, to me it's important to establish my sample space, the size of the sample space first and foremost. It makes life easier. It makes it easier to understand what we are doing. And so the top is simply 6 times 8. The bottom needs to be calculated. Just for the sake of argument, if you need to see the denominator, combination of 14, 2 is 14 factorial over R, which is 2 factorials, N minus R, which is 14 minus 2, or 12 factorials. So I hope you see that the top would be 14 times 13 times 12 factorials. The 12 factorials drop. 14 and 13 divided by 2 factorials. 14 divided by 2 is 7, and you can easily calculate. We're going to go to the next example.
A combination lock consists of the 26 letters of the alphabet. If a 3-letter combination is needed, find the probability that the combination will consist of letters A, B, C in that order. The same letter can be used more than once.
When you make up a password, a code, you understand that ABC again is not the same as BAC. If we were to choose different letters, it becomes a permutation. But it is important, even if this is not given, we should assume there is no restriction because it doesn't mention it. And so what you're looking at really is the total possible outcomes, your sample space. And your sample space, using fundamental theorem of multiplication principle. This is the first choice. There are 26 letters. Here's the second one. There is no restriction. I can use the same letter. Again, 26. The third one, no restrictions. Same number can be used. And that would be the total number of outcomes. Their product, which is simply put equals 26 cubed. If the restriction says the same letters cannot be used, that meaning you can't have AAA. Then what happens if we can't use the same letter? This changes to 25, this changes to 24. So it becomes a 26 times 25 times 24, or the permutation of 26, choose 3, or 26 times 25 times 24, because there are 3 spots. 26 cubed, we end up with 17,576 possible. We call it combinations, but it's really a permutation. In other words, 17,576 possibilities. And what would be the probability, therefore? Find the probability that the combination will consist of the letter ABC. There is only one way to get that. So the probability of ABC is N of ABC over N of S. The denominator is given, 17,576. The top, there is only one way. And that's the answer. And this is what I mean by writing a probability as a decimal. It's really not a good idea in a case like this. You probably want to leave it like that. If you were to write it as a decimal, this would become a number very close to 0. So you really have to carry out a lot of decimal. So you can stick with the fractional format or the decimal format. And again, as always, when you do your work online, you follow the instruction.
In a horse race, a trifecta bet is won if we select the horses that finish first and second and third in the correct order. There are 19 horses in a race. How many different trifecta bets are possible?
First, this is the definition of a trifecta is given to us. What we should know that the size N is 19 and R is 3 trifecta. Now we need to figure out whether order is important or not. And because trifecta refers to finding out the proper order of winning the race, it is a permutation of 19 choose 3, n factorial over n minus r factorial, and you take it from there. The denominator is 16 factorial, and for the top we can write 19 times 18 times 17 times 16 factorial. You end up with 5,814. The next one says, what is the probability of winning? There is only one way. There is only one way we can win, 1 out of 5,814 ways. The last part asking, so if that is the case, do all different possible trifectas have the same chance? And the answer is, although there are 5,814 different possible trifecta bets, not all of them have the same chance of winning because some horses tend to be faster than others. Let's look at the next example.
When designing surveys, pollsters sometimes repeat a question to see if a subject is thoughtlessly providing answers just to finish quickly. For one particular survey with 10 questions, 2 of the questions are identical to each other, and 3 other questions are also identical to each other. For this survey, how many different arrangements are possible? Is it practical to survey enough subjects so that every different possible arrangement is used?
So if you have the same question, but different answers from the same person, that means the person didn't bother to read the questions. And so when they check it, they say, okay, that they may toss it. Here's the way we look at it. And there are 10 subjects, 10 questions, okay, 10 objects, whatever you want to call that. 2 are identical in one case, and in another case, 3 other are identical. And the remaining 5, there are a total of 10, are simply different. So we can use this formula that we have seen before, simply known as, it's a permutation rule, that it is known as distinguishable permutations. So with that being the case, we are looking at the top right formula. So the number at top is 10, and at the bottom we have 2 factorials, we have 3 factorials, and the rest of them are all 1 factorials. Now we're going to write that just because we want to make sure everybody understands. But these parts, we write them because the numbers at the bottom, 2 and 3, and all those ones, they must add up to 10. But all of this, even if you don't write it, the calculation works fine. I just want to make sure everybody understands how this formula works. So normally we write that to tell our readers how things go. And now we just put it into a calculator and we end up with the answer, which is a huge number when you think about it, 302,400 different ways. According to statisticians, for typical surveys, the number of respondents is just about 1,000. Let's go over the next example.
In California's Fantasy 5 lottery game, winning the jackpot requires that you select 5 different numbers from 1 to 39, and the same 5 numbers must be drawn in the lottery. The winning numbers can be drawn in any order, so order does not make a difference. How many different lottery tickets are possible? Find the probability of winning the jackpot when 1 ticket is purchased.
So understanding the situation, we have the N being 39, R being 5. We are going to deal with 39 numbers, and we're going to choose 5. The winning numbers can be drawn in any order. So order is not important, which means right away we are dealing with a combination. We are dealing with a combination. And so all you have to do, calculate this combination and come up with the answer. So with that being the case, we are looking at combination of 39, choose 5, 39, choose 5, and do the math. 39 factorial over 5 factorial over 39 minus 5 factorial. Okay, now of course, this is 34 factorial. And again, you're not expected to do this by hand, but if you were to do that, you keep the 34 factorial in the denominator, and the top becomes 39 times 38 times 37, 36, 35, and then you stop at 34. So in other words, this one cancels out this one, and it gives us 39 times 38 times 37 times 36 times 35. Okay, so you multiply those numbers, you divide by 5 factorial, or you can write the 5 factorial as 5 times 4 times 3 times 2 times 1. Do the simplification and put the fraction, get rid of basically the denominator and come up with the answer. Now, part B, sadly, the order of the animation wasn't right. So what is the probability of winning is would be very simple. N of winning over N of S. There is only one way to win. Come up with the 5 correct answers. So 1 out of however number we got in part A, in this case is 575,757 different ways. So 1 out of that. That would be the probability of winning. And we are going to move on to the next page.
In the game of blackjack played with one deck, a player is initially dealt 2 different cards from the 52 different cards in the deck. A winning blackjack hand is won by getting one of the 4 aces and one of the 16 other cards worth 10 points, tens and faces. The 2 cards can be in any order. Find the probability of being dealt a blackjack hand. What approximate percentage of hands are winning blackjack hands?
So we are going to write the givens. When you are dealing with a hand, order is not important. You want to get a specific hand that you're interested in. You just want, let's say, an ace and a 10. It doesn't matter 10 comes first or ace. And the definition of a blackjack is given in case we are not familiar with that. So basically an ace and either a face or a 10. Does order matter? We have to. The answer is no, order is not important. So in essence, you're looking at the combination. So what do we have in a deck of cards? We have how many aces? We have 4 of them. Tens, we have 4 of them. How many faces? We have 3 times 4 or 12. So I want to make sure everybody understands how we arrive at these numbers, okay? So again, number of aces is 4. Number of tens is 4. Number of faces, there are 3 faces, 3 types of. So we have Jack, Queen, and King. There are 3 types, 4 suits. We have 12 plus 4, 16. So the number of blackjacks, therefore, would be 4 times 16. There are 4 ways to get aces. There are 16 ways to get tens and faces. So it's 4 times 16. But what is the total number of possible hands? We want 2 out of the 52 cards. So combination of 50, choose 2. Combination of 50, choose 2. Therefore, the probability of blackjack is N of blackjack over N of S. Now again, you can say simply 64 is the numerator. You can say 4 times 16 is the numerator. Or you can say C41 times C16 1. However you want to put that. And the denominator is C52 2. So the top, C41 becomes 4. I think I mentioned that. Again, I'm going to repeat that. C and 1 becomes N. So C41 is 4, C16 1 is 16, and we've already seen that, okay? We already have justified the answer of 4 times 16 equals 64, but again, going step by step with the combination. The denominator is 52 factorial over 2 factorial times 52 minus 2 factorial. 2 factorial times 52 minus 2, and that really becomes 50 factorial in essence. Simplification and putting it into a calculator gives us 64 over 1326 or 32 over 663. If you want to put that approximate percentage, is about 4.83%. Now, before we move on, I want to show you actually how to simplify this fraction if you want to do this. So first and foremost, this is 50 factorial. So the top is simply, I'm looking at the bottom, which is 52 factorial over 2 factorial times 50 factorial. You can bring the 2 factorial and the 50 factorial at top. This fraction, again, I'm showing you a complex fraction in case. This one would be 4 times 16 times 2 factorial times 52 minus 2. 50 factorial over, simply put, 52 factorial. See that this can be simplified. And the way you simplify it, this can go away. This can go away and changes to 52 times 51. And now you simplify and you end up with this fraction. This is it. And just quickly, a second method on that, multiplication principle. Probability of getting a blackjack would be the probability of first card being ace and second one be either 10 or a face, or vice versa. Probability that the first one is a 10 or face and second one is an ace. Okay, if you want to go this route. So there are 2 of them that you want to combine. So the probability that the first card is an ace is 4 out of 52, and the second one is 10 or face is 16 out of 51. When you're looking at this portion, you are looking at this one. Getting an ace, 4 out of 52. Needless to say, it can be simplified. Now, if an ace is gone, then total size of 52 goes down to 51, but the total number of 16 faces and 10s remain intact. So 16 over 51. With the second case, the first card is 10 or face, and the second card is an ace. So this one is the same as the second part, 16 out of 52. Again, it can be simplified times 4 over 51 because they are dependent. Since they are dependent, the sample size shrinks by 1 because one card is drawn.